Halogenation of alkynes, that's going to be the topic of this lesson. And once again, this is going to be analogous to the same reaction we saw with alkenes. We'll just once again have the option of doing it either once or twice with an alkyne. Now, this lesson is part of my brand new organic chemistry playlist. I'll be releasing these lessons weekly throughout the 2020-21 school year. So if you don't want to miss one or any of my future playlists, subscribe to the channel, click the bell notification. You'll be notified every time I post a new lesson. All right, once again, let's review the halogenation reaction with alkenes. And you might recall we use Br2 and an inert solvent like either CCl4 or CH2Cl2. And in this case, it's an anti-addition. It adds a bromine to each side of the alkene. So in this case, because we're adding two of the same thing, that there's no such thing as Markovnikov or anti-Markovnikov when you're adding the same atom to both sides. But it is an anti-addition, so it does have a stereoselectivity associated with it. And you might recall that it goes through a three-membered ring intermediate we call a halonium ion, and specifically in this case, it's a bromonium ion. With chlorine, it would be a chloronium ion. And that's what it does for alkenes. And when you attack one of these lovely halonium ions, you have to attack from the back side, very SN2-like attack. And that's the nature of what makes it an anti-addition. Well, we're not completely sure of the exact mechanism here, because as we'll see, this will give a major product through anti-addition, but you can also get the syn-addition product as well. And so the mechanism can't be exactly the same as what we do for alkenes, because we don't get exactly the same result. But in this case, we have the option of once again adding one equivalent or two. If we add one equivalent, in this case, we got 1, 2, 3, 4 carbons. So 1, 2, 3, 4 carbons. We'd still have an alkene here, but we'll have added a bromine across the alkene once here. And in this case, that would be the result of anti-addition, but it turns out we can also have the result of syn-addition as well. The anti is major, the syn is minor, but they both occur, and that's why, again, the mechanism is somewhat left in question what's going on. But once again, we also have a chance of adding a second equivalent. And you're going to add bromines once again across the alkene. And so now we've added 2 molecules of bromine across the alkene. Both of these carbons each pick up 2 bonds to bromine in the process. So if you had just one equivalent, stop at the alkene, both E and Z. If you had 2 equivalents, or you just say you add excess, then go all the way to the alkene and add 2 equivalents of Br2 across that alkyne from the get-go. If you have found this lesson helpful, would you consider letting out a big smile? It's a great day, and this was a short lesson. Happy studying.